Favorite videos from 2023. Here is another video in our series on building different types of A-frame homes. And in this one here, we will build a roof that will shed a little bit of the snow easier than in the previous example. And there were a few comments in the previous example that suggested what a horrible design it was. And I'm not going to argue with that. I'm just trying to provide different ideas in the video for people who might be building something like this. So let's go ahead and get started and take a look at our back wall. We are going to have a 2x4 wall in the back, a 2x6 wall in the front. And we're also going to extend the wall to sit on top of the roof sheathing. On the 24 and 12 pitch roof on the main house, we're going to have a 12 and 12 pitch on the garage. And again, a 2x6 wall here. That's so that we can put a larger beam in for the garage door header. And if you notice, we're going to have double trimmers here. You might even do better off with a post, maybe a 4x6. And don't bother asking what size lumber I'm using in the video because I can't provide you with the lumber sizes you're going to need in your area. If you've watched enough of my videos, you know that. And you can always make the back wall a 2x6 if that's something you need to do. And in this video, I'm not going to have a door coming from the main unit here, the A-frame, into the garage, and part of the reason for that is the drop that I have here. You can see the difference in the floor, and it looks like it's a little bit over a foot. That's going to create a problem for our door opening. However, I'm not about to suggest that you can't modify it to create a door opening from this side of the building into the garage. Next up, let's go ahead and install our rafter ties. If you want to install ceiling joist, you can. We're going to use rafter ties here going in this direction, and then some ties going in this direction. We're actually going to connect it to the rafters in the A-frame part of the home and run it all the way across to connect it to the exterior wall here to give it some support. We don't want the wall moving, and these braces will help with that. And of course, I have two of them flat, one here flat, and one on edge to provide you with a different example there of how you might connect them, along with how they might connect to the rafter ties. And here I had to attach a couple of blocks so that I could connect the brace that will be thoroughly nailed to the other support brace that will be sitting on top of the rafter ties. And you should attach all of this stuff together. End nail the flat board to the rafter tie, toe nail this board to the rafter tie, and again, you can just end nail, drive some nails down through the 2x4 into the rafter tie, and then drive some nails through this 2x4 into this 2x4, and then some nails to connect the rafter here to the brace. And hopefully you don't need more information on that. I don't put a lot of nailing information in the videos. They're kind of more meant to provide you with design ideas. And I'm kind of going on the fact that you already know how to connect this stuff together. If you don't, I do have plenty of videos showing you how to connect everything together. And you can find those on our website. Let's go ahead and add our rafters. Again, a 12 and 12 roof pitch. And each one of the rafter ties will connect at 4 foot on center to a rafter so that we can get a nice connection all the way through here. Rafter ties are 4 foot on center. Our rafters are 16 inches on center. So every third rafter will connect to a rafter tie. And the rafter ties are used to prevent the walls from spreading and the ridge from sagging. And again, I do have more information on that at our websites. Let's go ahead and put our fill in. Zoom into the bottom here to give you an idea how the rafters are going to be sitting on top of this wall here. And I went ahead and put my stud underneath the rafter since I'm going to have a single plate here. If you want to add another plate, then this wall stud doesn't need to be directly underneath the rafter. Next up, let's go ahead and take a look at the ridge. And I went ahead and had the ridge sit on top of our support boards here. You can always have the ridge sit on top of the sheathing, but I went ahead and did it so that I could show you how these support boards basically go up and kind of form a peak here, where if I was to run this through, and have it sit on top of the sheathing, I just wouldn't have this. And I would imagine some engineers would rather have the ridge sit directly on top of these support boards instead of the roof sheathing, especially if the ridge won't be sitting on top of a rafter. Next up, let's go ahead and head over to the other side. Give you an idea how the sheathing is going to kind of connect into here, run straight on through. And since this is a 45-degree angle, you could always shape the top of the ridge. That wouldn't be too difficult to do with a 45-degree angle. And of course, how the rafters will blend in, create a flat surface through the fill area. And our blocks, we're going to shape the top of the blocks. Again, not difficult to do with a 45-degree angle. However, it would be difficult to do for steeper roof pitches than a 12 and 12. And of course, our wall here, this will be our firewall. We're going to need to have a firewall to separate the garage from the living area. And if you're going to put a door from the garage into the living area, you're going to need a fire-rated door also. And of course, a better view of how we're going to use these boards here to connect to the 2x4 wall framing studs to provide us with some more strength to prevent the wall from moving in and out. And you could always space these braces closer together. I have them at 4 foot on center. You could use 32 inches on center to make it a little stronger. Next up, let's go ahead and add our fascia board and take a look at the bottom here. And I want to kind of give you an idea if you're going to install a soffit at the bottom and the soffit's going to come all the way across here, you're going to end up with kind of a different section here. And there are a variety of different ways to finish that. I can go ahead and provide you with some of them. Just let me know if you need more information on that in the comment area. And of course, our lookouts are going to be spaced 32 inches on center, and our collar ties are going to be spaced 48 inches on center. And try to line the collar ties up if you can with the rafter ties. And we're going to move the collar tie to the other side so that we can build our wall here. So instead of having it on the right side, we're going to put it on the left side so that it doesn't interfere with our drywall. Otherwise, we would have to drywall around it. And I don't even know if you'd really need a collar tie on this one because we do have the wall. A back view of this area here. And let's go ahead and take a look at the gap between the bottom of the fascia board and the sheathing. This will allow us to install roofing materials underneath this section of the roof. And this might require you to leave some of the sheathing off so that the roofer can install the roofing materials underneath this area here. It's going to be a little more difficult to do if you have the sheathing attached. A lot of times we'll just leave a board. We'll have a piece of the sheathing that might be this big here, cut separately so that the roofer can remove this section, install their roofing, and then reattach the sheathing, nail it off, and then install their new roofing materials over this section. And I don't know if I have a video on that. Go ahead and take a look at the other fascia board corner. The blocks and how they're going to attach to the rafter tie. You could always run the block past and have the rafter tie sit behind the block if you're looking for a different type of assembly method. And of course, our shaped fascia board. And we're going to have to do some notching here to make this side here blend in with this side here. Going to have to look something like this. Next up, let's add the roof sheathing and start wrapping the video up here. Roof sheathing, not too exciting. We've seen it before. And for those of you wondering why I didn't have a full sheet here, I was about 3 or 4 inches short at the top. Or in other words, if I used a 4 foot wide piece of plywood or OSB here, I would have needed to attach a 3-inch piece to the top of that. So for example, instead of having 48 inches here, I had about 52 inches. And if your engineer does not allow for something like that, for example, if they have a 2 foot minimum width, then you're going to need to do something like this here and waste a little bit of roof sheathing. In this video, I am going to try something different. Feel free to share your opinions with us in the comment area about something I might have missed in the video. So let's go ahead and jump right into this thing. We are going to have a set of stairs here with 4 steps and a handrail. This is not a guardrail. And the reason why I'm suggesting that this isn't going to be a guardrail is because if somebody was to actually put enough pressure on the guardrail over here, there's a very good chance you could just simply flip the stairway on its side. So if you were going to build something like this and use this as a guardrail, you might consider fastening the stairway securely to either a concrete floor or a group of concrete footings. So with that said, let's go ahead and start taking this thing apart and provide you with some measurements. Now, another thing I want you to keep in mind is that I have drawn this stairway with a computer program and have not verified any of the measurements at all. Feel free to share with us any problems you might have had assembling this stairway, along with any measurements that might not be correct. So again, I'm just kind of taking you on a tour here to show you how everything could be put together. And we are going to be using 2x8, 2x6, and 3x12s for our treads to create a stronger stairway. I have this same stairway designed with 2x12 treads and 2x12 decking. However, I don't know if that's going to be strong enough for your project, so you can always make it a little stronger by adding thicker lumber. Next up, let's go ahead and separate the stairway into a couple of sections because we are going to be assembling some of the stairway in sections. For example, we're going to assemble this section, and this section first. And if you're not interested in the handrail, you could always shorten the lengths of these 2x4s and make these boards a little bit longer, get rid of this board here, and get rid of the notches that you were going to cut here to prevent the lower boards from extending through that side of the stairway. And if you noticed, I built this side a little different than the other side just to provide you with 2 different examples. You can use either one or a combination of both of them. And I won't be providing you with the lengths of these because you could simply cut these in yourself or add some of these other numbers together to get the lengths that you need. And hopefully you can see all of the lengths here: 3 foot 9 3/8 inches, 4 foot 7 7/8 inches, 5 foot 6 3/8 inches, and then of course 6 foot 4 7/8 inches. And pay attention, this 5-inch measurement is critical because once we add our 2.5-inch thick stair step to the top here, it's going to provide us with a 7.5-inch riser. And if that doesn't make sense, study the model a little bit further to see if it does make sense. And when I'm referring to a 2x8, the 2x8 is 1.5 inches thick by 7.5 inches wide. Our 3x12s are 2.5 inches thick and 11.5 inches wide. If you're dealing with lumber dimensions that are different, you might need to adjust some of the measurements in this model. Again, you can get a pretty good idea at what the measurements are here. Our steps are going to be 10.5 inches deep to provide us with a 1-inch overhang. And you can always adjust these measurements to make these boards a little bit longer or a little bit shorter depending upon the design you would like to get for your stair steps. So not too difficult here. You can see where the measurements should be right on the money here. 3 foot 2 or 38 inches for these boards here. And I'll leave it up to you as to whether or not these boards need to be treated or the bottom boards here need to be treated lumber, depending upon what the stairway is going to be sitting on top of. Next up, let's take a look at the measurements for the other side. And these measurements here might be a little different than the boards on the other side. And hopefully you can see the measurements here that all make sense. Again, our 10.5 inch deep stair steps, an 1.5 inch notch to be cut into our boards here for our 1.5 inch thick lumber. And don't forget that these boards will need to extend past the outside of this board here 3.5 inches. So keep that in mind when you're putting this section together or connecting it to the other two sections. Again, 2x8 lumber here that's going to be 7.5 inches tall to provide us with a 7.5 inch riser height. Again, these boards can be ripped down and made a little bit shorter. And if you were going to make these boards a little bit shorter, the handrail is going to need to be modified because the angle of the handrail is going to change. And you can attach all of these boards together with 16D nails or screws, and you can always use smaller or longer screws if you need to, even framing hardware. You might be able to use some type of framing anchors or straps to create stronger connections. Next up, let's go ahead and head over to our decking to provide you with some measurements for that. We are going to have an 1/8 of an inch gap in between the decking boards, and we will be installing a board underneath the tread. This right here will prevent a 4-inch round sphere or round ball from going underneath the section of the stairway. And I'm not going to go into all the details of why we're doing that, but that might be one of your local building codes. And if it is, you might consider double checking all of the measurements in this stairway to make sure that it's going to work. Next up, let's go ahead and take a closer look at the hand railing and provide you with an example of why we're extending this board 3.5 inches out. And that will be so that the post, these 3 posts, can sit on top of them and securely fasten to them. And hopefully that makes sense. Next up, let's take a look at the handrails in pieces here so that we can provide you with some measurements. And again, hopefully you can see all of the measurements here. 1.5 inches here, and then 2 inches thick down here, 2 foot 8.5 inches here. And keep in mind that if you're off just a little bit on some of these measurements, or if your lumber is a little bit thicker or a little bit thinner, then some of these measurements might not work out as well. And again, 2 foot 6.5 inches here. These balusters will be the same as the ones on the other side. And we will be shaping the top of this post here along with this board here. This one might be a little tricky to cut, and this will be a 45-degree angle here, 17.8 degrees here. And these angles don't need to be perfect. They do not need to be exactly 17.8 degrees. 18 degrees or 17 degrees is going to be close enough. Unless you're a perfectionist, then go ahead and make sure that you're using the exact degrees here. I am not that much of a perfectionist, so don't need to get things that close. So again, a nice example of the lower section of the handrail here. And everything here will be 35.5 degrees. The end of this board, these boards, this angle here, this angle here, and then this angle here will be a 90-degree angle off of this line here. And of course the measurements for the lower handrail. And then after we take a closer look at these measurements here, we can go ahead and start putting this thing together. And again, you can use nails, screws, any fastening devices you think are going to work for your project. If it's going to be outside an exterior stairway, then make sure that you use corrosion-resistant materials like galvanized zinc or stainless steel. And all of this stuff right here can be assembled on a flat surface. That is, if you have a flat surface to assemble them on. If not, I would find a flat surface because it's going to make your job a little easier. And then once they are fastened together, we can go ahead and proceed with the next step, which will be fastening them together so that it will end up looking something like this. And keep in mind that this corner can be built differently. You could always just put this post on the outside and then extend the decking another 3.5 inches. Let's go ahead and take a look at it from the inside, and we can attach this board to the post here, because you have already attached this board here to these boards over here. However, on the other side, you might not have anything to attach these boards over here to until we attach this section, which will look something like this. So once you have this section put together, you got a pretty good idea what the stairway is going to look like, along with how you're going to be attaching the treads and the decking to that section. Now, I'd strongly suggest installing this board here, just simply nailing it or screwing it to the bottom of the step before assembling it, before putting it in place, because it would be very difficult to attach it afterwards. And you might need to use some longer screws, something that might be 4 or 4.5 inch and even longer screws or nails to attach the 2.5 inch thick materials to the lower section of the stairway here. Next up, let's take a look at a couple of connectors that you might consider using, like a piece of angle iron here, where you can either bolt the angle iron or use a lag screw to attach this section here to the upper part of the tread, or a bolt that will go all the way through. But something here is going to be needed to make this section a little stronger. And of course, that would become self-evident after you installed it and didn't install any hardware or connectors like this. And if you're not interested in installing this until after the stairway is built, that's fine. If this is a little wobbly and doesn't seem strong enough, then go ahead and try using something like that. As far as these posts go, we can always install some bolts through them also. I don't think nails or screws are going to be strong enough to provide you with the support you're going to need. However, you could always try them and then add some stronger connectors later if it's not going to be strong enough. Another thing to think about when you're positioning the bolts is to make sure that they're not going to be in the way of other pieces of lumber. For example, these bolts here might need to be moved over a little bit further to avoid having the washer sticking out a little bit further on the front there. And you can see where this one here is moved over a little bit, and where we've used a strap here. Just went ahead and installed a corner strap to make this a little bit stronger. However, something like this might not be very attractive, and you might consider using something else if it's going to create problems for the exterior view and design of the stairway. Next up, let's go ahead and take a look at the handrails. I would suggest pre-assembling both of these, but not this one here. This one should be installed in pieces. However, for this one here and the other one, you can go ahead and assemble them and then attach them to the stairway. And we're going to be using 1.5 inch by 1.5 inch balusters here that will be centered in the 2x4, leaving us with 1 inch on each side. So make sure that you understand this, because you're going to be laying out the position of the balusters with these lines and a few measurements. And those measurements should look something like this: 5 1/16, 5 3/16 all the way through, and of course a 45-degree angle here. Just kind of zoom in and take a look at some of these measurements and how they are laid out to position the balusters for your handrail. And of course, this one here is coming right off the corner here. And we are going to be attaching the side balusters to the posts. And the reason for that will be to make this section of the handrail a little stronger. And of course, the spacing will be the same from that point over, because this and this should line up here. This one and this one won't be lining up, and I'm not going to bother explaining why they don't need to line up. Just simply take a look at the assembly and how it's going to attach to the posts and the rest of the stairway. Next up, let's take a look at the other section along with the measurements of that section. So again, not too difficult coming off the corner here. And this baluster will attach to the 4x4 post. And 5.5 inches, this is only 1/16 of an inch less than 5.5 inches. With a 1.5 inch wide baluster is almost the maximum distance for our 4-inch sphere. You cannot pass a 4-inch round object through any section of the stairway, including the balusters. So you might consider adding another baluster and changing these measurements to reduce the distance in between the balusters. to less than 4 inches, maybe 3 3/4 or 3.5 inches, to prevent any problems with the building inspector. Because if they grab their measuring tape and it's 4 inches at any spot here, they're not going to pass the stairway. Or should I say, they might not approve of the stairway and the project. And again, we're in a 1 inch space here. The balusters are centered in the 2x4. Next up, let's go ahead and secure this part of the handrail to the posts. And you can do that by using 16D nails. In our example here, we're using 16D galvanized nails to attach the top board to the top of the post on both sides. Again, 45-degree angle here. And we're going to be attaching the bottom railing with toenails, angled screws, and we can even use smaller nails here to attach the balusters to the post, maybe some 8D nails, and you might consider pre-drilling holes to prevent these boards from splitting if you are going to use larger nails. Next up, let's go ahead and install the other side, again similar to the way we did the previous section. And again, angled nails or screws down here. You can use screws here, just pre-drill some holes, and you can pre-drill holes for every part of the stairway if that's going to work better for you. Now with the next section of the stairway, we're going to install the top board first because we're going to be using that to get the measurements we need to install the bottom board. And again, it wouldn't be a bad idea to pre-drill your holes for something like this. Small boards like this tend to split and break when you're driving nails through them, especially if they're larger nails. After you have the top rail installed, you can install the balusters on each side, securely fasten them to the post, or before you fasten them to the post, you can mark the bottom. You can mark the position of the bottom board or the bottom rail so that you can attach that first. So I could always install this board first and then use these to mark the location of the bottom board, and then securely fasten that board to the posts and then install your balusters. And again, you can always use screws or nails to connect the bottom board to the post. But again, it might be easier to install the nails this way. And to do that, this board here might need to be installed after, not before. Next up, let's take a look at the measurements I have for the balusters here, spacing about 6 1/4 inches. And the angles for these boards were mentioned earlier in the video. So you can just simply mark your 1 inch measurement here, create a straight line here, and then lay out your baluster boards and attach them to the lower and upper boards. And all of these boards can be attached by driving a screw or a nail through them. Same thing with these boards up here. And again, you might need to pre-drill the holes for accuracy and to avoid splitting the balusters. Another thing you could consider doing here would be to use a full 2x4 instead of a 2x2. In this video, I will provide you with the framing square ratios that you might need to build a hip roof. The video will not provide you with any calculations for the roof framing components, but will provide you with methods you can use to set up a framing square to lay out those components. So let's go ahead and get started with a plumb cut. A plumb cut will be any part of the roof framing that is going to be vertical, like this section of the roof ridge and these common rafter cuts. And then the level cuts will be any part of the roof framing that will be running horizontal. And I didn't mention this one in the last roof framing video for building gable roofs, but another cut that we're going to need will be a square cut. And a square cut will be any part of the roof framing that comes off of a component at a 90-degree angle, or a square cut for the roof overhang. And if that makes sense, let's go ahead and set up our framing square for a 4:12 roof pitch ratio. And if you're going to be using a 3:12 roof pitch, then you would just simply lower the framing square, keep the 12 in the same spot, at the edge of the roof framing rafter, and then reposition any part of the framing square on this side to match the roof pitch ratio you're going to need for your roof framing project. So again, in our example, we are going to be building a roof with a 4:12 roof pitch. And all plumb cuts will be made from this part of the framing square, like this one here on the seat cut. And then all horizontal marks will be laid out from this part of the framing square, like this one here that is going to be sitting on top of the wall framing. And here's an example of how you can reposition the framing square by simply sliding it up or down the edge of the roof rafter until you get it into the position where you need it to be to make the mark for your seat cut. And we can do the same thing for the plumb cut or the vertical cut. We just simply reposition the framing square by sliding it either in the left direction or in the right direction along the bottom edge of the roof rafter. And again, the roof ratio for the seat cuts on the common roof rafter will be 4:12 for this roof. Next up, let's go ahead and head to the top of the roof rafter where we are going to flip the framing square over. We're just simply going to rotate it 180 degrees so that we can lay out and mark the top of the common roof rafter. And again, you can see where the ratio is 4:12 here. This is not going to be the same for the hip. And an example of how the ridge will need to be level. And in our example, we will have square cuts on each end of the ridge. Next up, let's go ahead and take a look at the jack rafters or the fill rafter cut at the top. And this is also going to be a 4:12 plumb cut, the same as our common rafter, except this is going to have a 45-degree angle on it. And if you notice, the bottom seat cuts are going to be the same for the common rafter as it will be for the fill or jack rafters. Let's go ahead and head back to the top where we can take a look at how the framing square is going to be positioned to lay out the plumb cuts for our jack rafters. And like I mentioned, you will have a 45-degree angle because the hip is going to be running at a 45-degree angle from the walls that will be supporting the jack rafters. And to make a 45-degree angle on a framing square, you can just simply line up any one of the same numbers on the framing square. So I could use the 5 and the 5, I could use the 7 and the 7, or I could use the 10 and the 10 to create a 45-degree angle. Or you could simply set your circular saw or other saws you're going to use to make these cuts at a 45-degree angle. Next up, let's go ahead and figure out the roof framing ratios for the hip rafter. That is not going to be a 4:12. For the hip, we need the number 17, or if you really want to get precise, it's going to be 16.97 to make the plumb cut or any level cut we need for the hip roofs. And again, if your roof ratio is a 6:12, then you're going to line your roof rafter, then you're going to replace the 4 measurement by that measurement. If I have a 7:12 roof pitch, I'm going to line the number 7 up with the number 17 to lay out my hip roof rafter. And I'm going to do the same down here. And don't forget that you can rotate the framing squares if that's going to work better for you. Just make sure that the roof pitch ratios are correct on the framing square. Next up, let's take a look at the overhang ratio. And you can use the same ratio here if you're going to have plumb cut fascia board or fascia board that will be installed vertically. However, you won't be able to use it if the fascia board has a square cut on the end of it, like we're looking at in this example here. And I'm going to do another video on this in the future. I could not come up with anything that was simple and easy to explain because you can see here where it's a different ratio. And I actually thought I could flip the framing square over to lay out this part of the hip roof rafter, but I couldn't. And you can see here where this doesn't work. And the reason why this doesn't work is because the fascia board is going to be tilted. We could have used the 4 and 12 like we did for our roof rafters if this section of the fascia board wasn't angled. And even if we took the framing square and flipped it over to where we lined up our 17 and our 4, you can still see here where this is off a little bit. And I'm not about to suggest you can't do this, but I am going to suggest that it might not be perfectly perfect. So it might be easier for you to install the fascia board with a plumb cut on the roof rafter, because you will be able to use all of the ratios I've provided you with in this video. Or you could use a level to mark the lower end of the roof rafter. And this cut here would be at a 45-degree angle. And like I said earlier, the plumb cut will be the same at both ends of your jack rafters, your common rafters, and even the hip rafters if you use the ratios I provided you with in the video. Just don't make the mistake of using the 4 and 17 ratio for the common or the fill rafters, because the plumb cut down here is not going to be a 4 and 12, it's going to be a 4 and 17. These are going to be 4 and 12s, and these are going to be 4 and 12s. If you're building a roof with a 4 and 12 roof pitch, again, you're going to have to change the ratio numbers on the framing square if you're building a roof with a different pitch ratio. In this video, I will show you how you can use a simple math calculation to calculate the height of a mid-span roof beam. And this would be a beam that would be supporting the roof rafters in a large building like this one here. And hopefully by the time you finish watching it, you will know how to do it, and I will have taken all of the mystery out of this particular process of extremely complicated construction that can often be made a little easier with a video. So let's go ahead and throw some roof rafters in there to give you an idea that the top of the beam is going to fit into the seat cut like this. We are not going to be using the bottom of the roof rafter, or should I say most of the time we're not going to be using the bottom of the roof rafter, because roof rafters are usually going to have seat cuts in them. And these seat cuts will need to be the same measurement, otherwise they will need to be adjusted. And you're going to be able to use the same process here to calculate the height of the roof ridge also. And I do believe I have other videos on that. Make sure you go to the website and check those out in the home building, framing, and roof framing sections at our website. So let's go ahead and draw a little triangle here. And you won't have to draw this. You will simply use the building plans or measure over when laying out the wall framing, the distance from here to here. And if you notice, this point here is the same part of the roof seat cut. So don't measure from this side to the other side, or from the inside of the wall to the inside of the post. This is going to be critical for calculating the height or the difference in the wall framing. Remember, this is the top of the exterior wall framing where the rafters are going to be sitting on. And this will be the difference from the top of the wall framing to the top of the beam. Now, the first thing we're going to need will be the roof pitch. In our example here, we are going to be using a 4 and a 12 roof pitch, or a 4 to 12 roof ratio. And this simply means that for every 12 inches or 1 foot that we go over, we're going to be adding 4 inches, working our way up with a 4 and 12 roof ratio. If I come in 2 feet or 24 inches, I should be up 8 inches. Come in 3 feet, I'm up a foot, and so on. And you can do this a variety of different ways, but we're going to have to convert this, or the measurement we're going to be using here, into a decimal that will convert the inches to feet. So let's go ahead and break out our calculator, and we can simply multiply 9 feet times 4 equals 36 inches. So we're going to be up 3 feet at this point here. 9 segments multiplied by 4 inches of rise per foot gives us 3 feet. So we can write this number down, 36 inches, and then add it to what we come up with here. So let's go ahead and take 10 and turn it into a decimal, 10¼ inches, and I'm going to divide that by 12. We have 12 inches in a foot, and that will convert this to a decimal, and we can use this decimal here. This represents the measurement in feet. So 10¼ inches will convert to 0.8541, and then we can simply multiply that number times the rise to give us 3.41 and the number that we can add to 3 feet. So this would be 39 inches, 0.416, or 3 foot 3 inches and 7/16 of an inch. Now let's go ahead and clear this, and let's just say that I converted this to our decimal, and I'm going to add this to this, making 9.8541. So here's the 9 feet. Here's the decimal that was converted from 10¼ inches. And I can simply multiply this times our rise to get 39.4164, or 3 foot 3 and 7/16 of an inch. And if you're working with a 5 and 12 roof pitch, you're going to use the 5. If you're working with a 7 and 12 roof pitch, you're going to use a 7. I would convert this to our decimal that would represent feet, and then multiply this number times 7 for a 7 and 12 roof pitch to get the difference between the top plate, top of the wall framing, and the top of the supporting rafter beam. So let's go ahead and throw some walls back in here. Remember, the top of the wall framing, we go over level and then we come up. And this provides us with the top of the beam measurement. And then all we need to do is subtract the difference of the height of the beam to get the size of the post that we can install in our wall framing. And you can always use the same method here to calculate the rake wall, or the angled wall height that the bottom of the rafter will sit on top of. Now let's go ahead and wrap this video up by showing you the seat cut. Here we have a 3/4 inch notch in the seat cut, or the plumb cut of the rafter is going to be 3/4 of an inch. And we're going to have the same at the bottom. 3/4 inch notch here, 3/4 inch notch here. If I change those cuts, for example, if I was going to make this 1 inch, then I would need to adjust for the difference to calculate the overall height of the midspan support beam. Here is another question someone sent me. They wanted to get a little more clarification on what the building code says when measuring the riser height, the individual riser height for a stairway. Now in this case here, we're going to have a sloping tread. And the reason for this would be if you were going to have an outdoor stairway, you might install some waterproofing over it, and you're going to want the water to drain off of the stairway. You're not going to want it to collect on each one of the steps. So this is something you are allowed to do. However, my interpretation of this particular building code will provide us with a different measurement. You're not just going to be able to measure the height of the front of the riser like you would if the stair steps were going to be level, like we have over here. So over here we have a 7 3/4 inch riser. This is the same stairway without the sloping tread. So if you measure this one, you can actually measure the height of the riser, 7 3/4 inches, to get the individual riser height. However, on this one here, we're going to need to measure the distance from the front of the riser on the lower step to the front of the level riser on the upper step to get the riser height we're actually looking for. And in this example here, it will be 7 3/4 inches. Your measurement might be different. And the reason why I made this video is because someone suggested that they had an 8-inch riser and they were hoping to add some materials and slope the stair treads so that when the inspector measured it, they would have a 7 3/4 inch riser instead of an 8-inch riser, since 7 3/4 inches was the maximum in their area. And another way to calculate your riser heights would just be to simply count the amount of risers and divide it into the total rise. or the measurement between the lower level and the upper level. And keep in mind that this is my interpretation of this building code. Your building inspector, the people who work at the building department that you might be gathering information from, might not interpret it the same way. This will be the first video in a series of videos. I will be creating a playlist. I will put a link to that playlist in all of the videos, and if for some reason you don't have a link to it, let me know, along with letting me know if there's something in the series that I missed. And all of your questions, leave those in the comment area if you have them. So let's go ahead and get started with our first project. We're going to be using a straight 1x12. We're going to set it on top of the steps like this. And we could always use some tape to hold it to the wall if that's going to work. And the first thing we're going to do with this suggestion here is check to see if there are any gaps at all between the bottom of our board and the corner of the tread and the riser. And if there are any gaps at all, then we're going to have to use a different video. Even though this method can be used for both, we're going to focus on straight steps, straight lumber, and create a finished straight skirt board. So the first thing I want you to do is set your framing square on top of the tread, butt it up against the riser. And even though I don't have the inch marks over here, you can use yours or simply make a mark on the framing square like I did here. And it wouldn't be a bad idea to grab a piece of paper and a pencil and then go ahead and check all of the steps, including the first one down here. Set the framing square like we have it here. On each one of the steps, write down what the numbers are, and if they're all the same, great. And you can go ahead and proceed with watching the rest of the video. If they're different, this method might not work for you. And there are a variety of different ways you can do this. We're going to use a level and line the point of the framing square up with the point of the tread and the riser. And then we're going to use this to lay out our first step or our first notch that we're going to need to make in our skirt board. So here you can see where we're making a mark that would line up with the mark we placed on our framing square at the top, and then we're going to do the same thing at the bottom here. And then after we have the framing square in the position that we need, we can go ahead and draw the lines that we're going to use to cut out our notches for the skirt board. And it wouldn't be a bad idea to connect the two lines here together with a straight line, or a line that's going to be parallel to the top of the skirt board. And if you go to connect the two lines and they're off a little bit, then you might have a problem. And we'll need to watch another video in this series to solve that problem. Next up, let's go ahead and set the framing square into the next position. And you can see here where the marks are in the same spot as they were on the previous step. Then we're going to go ahead and reposition the framing square. And of course, you can see here where we have laid out the rest of the marks we need. And of course, after we cut out our notches, let's just go ahead and give you a couple of different views of our board here. And after you have done a couple of these, you might be able to lay them out on top of a couple of sawhorses, or at the very least, you'll be able to take the board over to and set it on top of something so that you can cut the notches out. You will not be cutting the notches out with the skirt board still up against the wall, like we have in our example here. After that, you know what to do. Slide it into position. And if everything works out okay, you shouldn't have any gaps in between the risers and the treads, and should be able to finish off the floor trim however you want to. You can see here where we are using this method here to connect the baseboards to the skirt board at the bottom and at the top. In this video, I will provide you with something that you might not be aware of, and that's the fact that you can install more drainage fixture units on a pipe that is sloping more. And even though it doesn't make any difference for a 1.5-inch pipe that allows a maximum of 3 fixture units, whether the pipe is sloping 1/4 of an inch or 1/2 inch per foot. And this means that the pipe will be dropping down vertically 1/2 inch for every 1 foot or 12 inches the pipe travels horizontally. However, it will make a difference if you have a 2-inch pipe, where the minimum slope is going to be 1/4 of an inch per foot. However, if you slope it 1/2 inch per foot, you're going to be able to add another 5 fixture units. And I do have another video on that. I'll put a link in the video description box to it. And a lavatory sink for a bathroom is usually going to be 1 fixture unit. So for a 2-inch pipe sloping 1/4 of an inch per foot, I'm allowed to have 21 fixture units, or 21 individual lavatory sinks. However, if I slope this pipe another 1/4 of an inch per foot so that I can get a 1/2 inch per foot slope in it, I can add 5 more lavatory sinks. And I know this doesn't sound like that big of a deal. However, these numbers increase a lot once we start increasing the diameter of our pipes. So for example, a 3-inch pipe sloping 1/8 of an inch per foot can have 36 fixture units. However, if it's sloping 1/4 of an inch per foot, it can have 42 units. 1/2 inch per foot, 50 units. And even that might not sound like that big of a deal. However, if we go to a 4-inch pipe and we slope it 1/8 of an inch per foot, we can have 180 drainage fixture units. 1/4 inch per foot, 216. 1/2 inch per foot, we can add another 70 fixture units for a grand total of 250 drainage fixture units. Now that's a big number. By increasing the slope from 1/8 of an inch per foot to 1/2 of an inch per foot. And of course, I will put the building code reference numbers in the video description area also. And don't forget to check with your local building department to make sure that your building codes are the same as the building codes mentioned in this video. Here is a helpful video for anyone who needs to know a little more information about the lumber used for their stair stringers. According to the 2015 American Wood Council Prescriptive Residential Wood Deck Construction Guide. And even though I cannot provide you with or verify that this information would work perfectly for every situation, I can tell you that I have seen 2x12 stair stringers used in a situation like this without any problems. And of course, the maximum length for an unnotched stair stringer is going to be measured horizontally, and that measurement will be 13 feet 3 inches. And to calculate the actual length of the stair stringer, you're going to need to do a little bit of math. And I do have another video on that. I will put a link to that in the video description box. Because the actual length of the stair stringer in this example, with a 7-inch individual riser for each step, is going to be just a little bit under 16 feet. And another thing I noticed in the drawing is that the treads are pulled forward and not centered like I would suggest in some of my books. So don't forget to do that if you're going to be using these guidelines to build a set of stairs for your deck. And the maximum length for a 2x12 stair tread is going to be 36 inches or 3 feet, according to this pamphlet. And they are suggesting that you use 2 number 8 3-inch long screws to attach the tread to a wood tread support board that will also attach to the stringer with 4 3-inch long screws. And they are suggesting to use a 2x4 here that will be the full length or width of the tread. And even though I've seen this used before, I've never built a set of stairs with it, because most of the engineers that I have worked with call out for using some type of a metal bracket. And I would also like to point out that the minimum size stair tread on all the projects I've worked on in Southern California have 3x12 treads and 4x12 stringers for something like this. In this video, we will be taking a look at the drainage plumbing for our two-story home building project. So let's go ahead and get started with the clean out located by the front door. And this would be used to clean out the drain pipe that connects the house to the sewer. Next up, let's go ahead and take a look at the roof vents coming out of the roof, and you can connect some of these together. I will try and show you that in a future project. And of course, the vents for the lower bathroom, along with the vents for the upper bathroom, and the laundry over here, and our kitchen sink over here. And you can see where this one goes all the way down to the kitchen sink. Next up, we will have a clean out at the back and a clean out behind the sink. I like to put these in, even though sometimes they're not required. If you can take the trap apart, you won't need a clean out. But I hate to say it, they're only a few dollars, and hopefully you never have to use them. But if you do, they could be a money saver. And the drainage line for the upstairs bathroom, the wash machine drain line with a clean out on both of these. Let's go ahead and take a look at a different angle on that plumbing, and then head over to our lower bathroom. Bathtub, toilet, sink. And I have a clean out under the stairs in a closet. And this might require some type of fire protection. It might need to be a rated fitting. And I will try to go over that in a future video also. Next up, let's go ahead and remove the concrete and the soil to give you a better idea of how everything is going to connect together below the concrete slab. And here we have the arm going to the bathtub and then connecting to the drain line. And then we have a vent here for our toilet. I'm not 100% sure that you couldn't get away with using this vent right here. You wouldn't need this one. Or you wouldn't really need this one because you would have this one. However, it's better to be safe than sorry. So I went ahead and put a vent in here and a vent in here. And when it comes to plumbing, I've seen a lot of things done a variety of different ways. So something that might work in my area might not work in your area, and vice versa. Keep that in mind when you're looking at this project. Next up, let's take a look at the wash machine drain line, and that will be draining into this line here, where we will have a clean out here to clean out all of this stuff here, just in case there's ever a problem with that. Next up, let's go ahead and pan out so that we can take a look at how the line is going to connect into here. This would be a 3-inch line here connecting into a 4-inch line. And this clean out here is going to clean everything out all the way down to at least this clean out. And then the kitchen drain clean out can be used to clean out this section of the drain pipe. Let's go ahead and take a look at it from the bottom here, give you a better idea of how the drain lines are working. And I don't have anything sloped in the video. It's a lot easier for me to draw it that way. Keep in mind that the plumbing pipes will need to slope 1/4 inch per foot. However, the 3-inch and the 4-inch drain lines can slope 1/8 inch per foot. Next up, let's take a look at the upper bathroom drain pipe layout, where we have the toilet draining into this line here, and then we have the sink draining into here. This is also a wet vent for the toilet, and you're going to need to extend a 2-inch vent pipe all the way through the roof. If this wasn't going to be used as a vent pipe for the toilet, this could have been 1.5 inches. All of this could have been 1.5 inches to here. Next up, let's go ahead and take a look at how the sink is going to hook up to the sanitary T-fitting that we have here, and how this is all going to connect to a combo sweep fitting over here. Next up, let's go ahead and take a look at the bathtub. We're going to have the trap over here. I had to move the joist. I had to relocate these 3 joists here. And I could have made this shorter here, but I wanted it to be in this stud bay here so that I could free this up for the bathtub and shower combo valve for the water supply, which I will be providing later on. And let us know in the comment area if you want to see it. If I get enough comments, I'll make it a little sooner than later. And we can see here where the bathtub is going to drain into our 3-inch line here, again with a combo sweep fitting, where we'll have 3 inches on the side here and 2 inches coming out here. And keep in mind that the bathtub can be 1.5 inches. However, I like to run a 2-inch line to here and then run 1.5 inches off of it and then 1.5 inches up. Even though I'm not entirely sure I did that in this example, this might be 1.5 inches all the way through. Next up, let's take a look at it from above here to see how the drain pipes are working and the vent pipe. Next up, let's remove the upper framing and the floor joist so we can get a different view of the plumbing. So no foundation or upper framing here. And if you need detailed information about the pipe fittings, let me know in the comment area. I'll go through and name each one of the fittings. However, I'm not going to do it if I get less than 10 people who want to see it. I went ahead and named them all in one of my videos and didn't get very many views on it. I think I got about 100 million views on it. I'm looking for 100 billion views on this stuff, but I'll settle for 50,000. A view of the kitchen sink and the clean out here, or should I say we have 2 clean outs, one for the 4-inch line, one for the 1.5 inch line, and a better view of the upper bathroom. Sink line here, toilet coming in here, bathtub here. These are all vents going up, and of course the vent would start from above the drain pipe fitting. The vent would be from here up for the dry vent and from here to here for the wet vent. And this one here would be a dry vent from here up. No wet vent here. Next up, let's go ahead and take a look at the wash machine drain line and how it connects to the 3-inch drain pipe. And then we can start wrapping the video up here with our last view of the lower bathroom and then the bathtub arm, toilet drain, vent, and then vent from here up. And this vent is going to tie into this vent here. And you could do the same thing with some of the vents in the attic. Here is another idea that I thought of. I've never seen it done before. That doesn't mean that it hasn't been done before. However, it might provide people who live in areas where the ground freezes and can push or heave concrete footings out of the ground. Another way to fasten the bottom of a stairway to the ground. And that would be to use footings and beams, something like this. I have an 8-foot beam here, and I kind of built it in a way to where the beam will create another step. And the reason why I'm making the video is recently I came across one where the individual had installed one large footing for each individual stair stringer. And that's a lot of concrete, a lot of footings, and could be eliminated if something like this was approved by your local building department. So let's go ahead and take a closer look. We are going to have footings. They are going to be installed below the frost line, and we're going to use hangers if necessary. Here we have inverted hangers on this end, and I have a little different situation on the other end. And we can notch the stringers to fit over the beam or use hangers to attach the beam to the stringer. And I won't be able to provide you with any lumber or footing sizes for something like this. Or do what most people do, just build it anyway and hope for the best. And you can use different hardware to attach the beams to your concrete footings. And you can even use treated lumber if you need to. And you could even forget about installing these joists by simply changing the direction of the decking, running it this way, and then run the decking this way for the rest of your stair steps. And something like this might work for your last step. If you need to lower the soil for some reason, you could just simply build a box and drive some stakes into the ground on the outside or the inside. Obviously, the inside is going to be better for this side here. And then attach the perimeter boards to the stakes, metal or wood, and then fill the box with gravel to create another step. And again, you're going to want to have it the same width. And the reason why you're going to be filling it with gravel is because, again, you live in an area where frost in the soil is going to be a problem. And if for whatever reason this ends up getting out of shape, deformed somehow, You can always empty the gravel to adjust the forms, or adjust the forms with the gravel in the box if that's going to work for you. Or you can raise the soil and then put a few inches of gravel on top of the soil, just as long as the water can drain out of the gravel. Next up, let's go ahead and put a couple of these stairways together to provide you with an example of how you could attach the two beams to one footing. And you can see here where they're breaking on the center of the footings and how the gravel can kind of go under here. You're not going to have a big problem as long as the gravel can drain the water away from the lumber. However, I get it. I don't have a lot of experience with the snow and could see something like this as a big water collector. The water's going to seep into the gravel, freeze, and then create problems for our lumber. So again, that might be another reason why you might consider using some type of ground rated or pressure treated lumber that would survive those kinds of situations. So hopefully this helps, or at the very least provides you with a few ideas that might help you get started with a project like this. And if you have any questions at all, feel free to leave those in the comment area, along with any tips, or someone might have built something like this and it worked great or it didn't work great. Let us know in the comment area.